What have scientists found on Mars?
Mars is a planet of mysteries and stark contrasts. Here, endless rocky deserts lie side by side with the tallest volcanoes in the solar system, while the surface is filled with traces of ancient catastrophes, gigantic canyons, craters, and tectonic rifts. The thin atmosphere is saturated with fine particles of rusty sand, and furious winds whip them into long-lasting, violent dust storms. This is the face of Mars, a harsh and enigmatic world. Let's take a closer look. Mars orbits the Sun at a distance roughly 1.5 times greater than Earth's. Its radius is almost half that of Earth's, and its mass is approximately 10.7% of our planet's. Surface gravity on Mars is nearly 3 times weaker than on Earth. Temperatures range from -153 degrees Celsius at the poles to +35 degrees Celsius at the equator. The total surface area of Mars is comparable to the combined land area of all Earth's continents, and it displays an extraordinary variety of landforms, from features familiar from Earth to utterly unique geological formations. Today, numerous automated scientific spacecraft observe Mars from orbit. By analyzing the data they've collected, one can easily spot a large, bright region in the planet's western hemisphere. This is Olympus Mons, the largest volcano in the solar system, and it is here that our journey across the red planet will begin.
Olympus Mons. Olympus Mons rises 26 kilometers above the surrounding plains, more than 2.5 times taller than Mount Everest. According to current scientific understanding, it is a shield volcano built up by countless layers of solidified lava flows. Unlike Earth, Mars lacks tectonic plates, so the magma source beneath Olympus Mons could remain fixed in one location for hundreds of millions, even billions of years. As a result, erupted lava spread over vast distances, gradually forming an enormous continuous basaltic crust. The average diameter of Olympus Mons is approximately 600 kilometers, and its total area exceeds 300,000 square kilometers, comparable in size to countries like Poland or Italy. At the center of the volcano lies a massive caldera formed by 6 partially collapsed volcanic craters. This central depression measures about 85 kilometers across and reaches depths of up to 3 kilometers. Olympus Mons is so tall that atmospheric pressure at its summit is 50 times lower than at its base, considering that Mars's atmosphere is already about 160 times thinner than Earth's. Conditions near the peak are nearly vacuum-like. This is one of the main reasons why landing a research spacecraft on Olympus Mons is extremely difficult. The atmosphere is far too thin to allow parachutes to slow a descending lander effectively. Most of Olympus Mons' slopes are remarkably gentle, averaging only about a 5% incline. However, near the edges of the volcano, the terrain drops abruptly in steep scarps that can be as high as 7 kilometers. The exact origin of these dramatic cliffs remains uncertain. Some theories suggest they were carved from erosion from an ancient Martian ocean, while others attribute their formation to the relentless force of powerful dust storms. After descending from Olympus Mons and surveying the surrounding region from above, one can observe numerous interconnected ridges and isolated mountains stretching thousands of kilometers away from the volcano's base. Their origin is likely linked either to massive landslides caused by the collapse of the giant mountain's flanks or to the movement of ancient glaciers.
Tharsis. If we travel southeast from Olympus Mons, we arrive at a vast region known as Tharsis. This is a volcanic plateau formed by solidified lava flows and covers nearly a quarter of Mars' surface. With an area of approximately 11.6 million square miles, roughly the size of Africa, it rises about 6.2 miles above the surrounding lowlands. Tharsis is ancient, with an estimated age of around 3.7 billion years. The region hosts numerous volcanoes, some of which are only slightly smaller than Olympus Mons. For example, Olympus Mons towers 11.8 miles above the Martian datum, making it the second highest peak on Mars. Its central caldera spans about 68 miles in diameter, while the volcano's total width exceeds 270 miles. Each year, during a brief seasonal window, a unique atmospheric phenomenon occurs above Olympus Mons. Sunlight heats the volcano's slopes, generating powerful updrafts that swirl fine dust into a dense, towering cloud. This plume can rise to altitudes of up to 18.6 miles and be carried by winds across vast distances. Scattered across Tharsis are deep vertical pits whose floors are impossible to see from orbit. The largest of these has a diameter of approximately 490 feet and a depth of at least 584 feet. Scientists believe these features are collapsed sections of ancient lava tubes, tunnels once formed by flowing molten rock beneath the surface. Tharsis itself is composed of dozens of interconnected shield volcanoes. Over billions of years, their eruptions released enormous quantities of carbon dioxide and water vapor into the Martian atmosphere. Mathematical climate models indicate that these outgassings could have produced an atmosphere 1.5 times denser than Earth's today. This serves as indirect evidence that Mars may have once had environmental conditions favorable for the emergence of life. However, due to the planet's relatively weak gravity, it was unable to retain this thick atmosphere over geological time, and gradually lost both its air and surface water.
Valles Marineris. Continuing eastward from Tharsis, we reach Valles Marineris, a vast branching system of giant canyons stretching up to 2,800 miles in length, 370 miles in width, and more than 6.8 miles in depth. Photographic evidence shows that the canyon walls in the central and western sections display a layered structure typical of sedimentary deposits found on the bottoms of large ancient bodies of water. It is highly likely that these canyons were once completely filled with liquid water. If so, the rock formations in this region could preserve invaluable paleontological evidence, potential traces of past life. The eastern portion of Valles Marineris features a chaotic, rugged terrain, a maze of numerous smaller canyons, chasms, hills, and plateaus. Farther north, the landscape gradually smooths out, transitioning into the relatively flat Utopia Planitia. Resting on this plain are the remains of the Spirit Rover and the Viking 1 lander, which in 1976 transmitted the first color photographs of the Martian surface back to Earth. Several hypotheses exist regarding the origin of Valles Marineris. One theory links its formation to tectonic stresses caused by the immense uplift of the Tharsis volcanic region. Another suggests that the canyon system may have been triggered by the colossal impact that formed Utopia Planitia on the opposite side of the planet, an event so powerful it could have fractured the crust globally.
Utopia Planitia. This is a vast, nearly circular lowland basin with a diameter of approximately 2,050 miles, most likely created by the impact of a massive asteroid. The terrain here is relatively flat and smooth. Utopia Planitia has been explored multiple times by robotic spacecraft. In 1976, the Viking 2 lander sent back panoramic images of its surface. In 2016, the SHARAD radar instrument aboard the Mars Reconnaissance Orbiter, MRO, detected extensive underground deposits of water ice mixed with dust. Then, in May 2021, China's Zhurong rover landed in this region. Since then, it has traveled more than 3,280 feet, over 1,000 meters, and transmitted hundreds of images back to Earth. However, it is not equipped to drill deep enough to reach the ice layer, which lies buried between 3 and 33 feet, or 1 to 10 meters beneath the surface. To the north, Utopia Planitia merges into the northern lowlands, a colossal basin that covers roughly 40% of Mars' entire surface.
Jezero Crater. If you travel southwest from the center of Utopia Planitia, you'll reach Planitia, and along its western edge lies Jezero Crater, a site that has captured the attention of scientists worldwide for over 4 years. Since February 18, 2021, the Perseverance rover has been exploring the crater floor accompanied by Ingenuity, the first aircraft in history to achieve powered flight on another planet. Jezero was selected as one of the most promising locations to search for signs of ancient microbial life. The crater formed approximately 4 billion years ago when a large celestial object struck Mars. It measures about 30 miles in diameter. Scientists believe it once held a lake, particularly during the Hesperian period, roughly 3.5 to 2.5 billion years ago, when Mars likely had atmospheric pressure close to Earth's and surface temperatures that may have reached plus 122 degrees Fahrenheit, plus 50 degrees Celsius. Rock samples collected by Perseverance already show clear evidence of prolonged interaction with liquid water. These samples are intended to be returned to Earth in a future mission for detailed laboratory analysis. For now, the rover continues its work. Its mission is designed to last up to 14 years, and ahead lie hundreds of discoveries and many miles of exploration.
Final thoughts. Despite all our efforts, Mars still holds countless mysteries. It's possible that within just a few years, humans will set foot on its surface for the first time. That moment will mark a new milestone in the exploration of the solar system and the beginning of an era of great discoveries. We'll be sure to bring you every update as it happens. Subscribe to our channel because the best is yet to come.